All right. Well, hello and welcome everyone to Sail into a Career in Nuclear Science and Technology. This is presented by the American Nuclear Society's Young Members Group with a generous grant from Constellation. Today's event is part of our See It, Be It Pathways to Nuclear Careers program developed for elementary through high school students. I'm Julie McCallum. I'm the secretary of the ANS Young Members Group, and I work at the Nuclear Energy Institute. I'm pleased to be here and happy to moderate this webinar today. So before I introduce our presenters, I do want to just cover a couple quick things just so you guys know ahead of time. If you have questions, please type them into the Q&A function down there at the bottom of your screen. We will attempt to address as many questions as we can, but we expect quite a few questions. The event will be recorded and a link to the recording will be sent out after the event later today. Additionally, if you want a certificate of attendance for today's event, you are able to request that via email. You can use the contact information that's going to be shared in the chat. And then last but not least, very important, we do want to ask that all participants adhere to ANS's Code of Ethics and Respectful Behavior Policy, which can be found at ans.org. So with that, got that all out of the way, I want to go ahead and introduce our guests. Today we have Dr. Arielle Miller and Will Schleper. So if you could, let's go ahead and start with Will. We're going to have them introduce themselves because this webinar is really all about their experience in the nuclear industry. So Will, if you want to go ahead and kick it off.
Absolutely. So my name is Will Schleper, and I am a junior at the United States Naval Academy, and I'm 23 years old, which is a little bit more peculiar for a midshipman as a junior to be 23, but that is because my path to the Naval Academy wasn't just a straightforward path. It was a path that had quite a few obstacles. Initially, I knew that I wanted to apply to the Naval Academy when I was in high school, ever since I was in like 5th grade. And the DARE police officer, the police officer in charge of the drug program, he'd asked all the kids what they wanted to be when they grow up. And, you know, some said doctor, some said firefighter. And I said, I want to work on nuclear war machines. And he kind of stopped and looked at me. He's like, oh, okay. Well, you know, fast forward to high school, I still had that dream. You know, I always wanted to be a nuclear engineer, specifically in the Navy. And I saw that the United States Naval Academy was an option to get your degree in nuclear engineering. And I thought, oh, perfect. I mean, there's no other organization that operates more nuclear reactors than the United States Navy. So I applied to the Naval Academy, and unfortunately, I was rejected. And after doing the Naval Academy Summer Seminar, the prior year to that, in 2018, I told myself, after looking at the campus and, like, you know, they told me about the school, I was like, no, this is what I wanted. Like, this is absolutely what I wanted to do, primarily because I saw that the classes are really small and the instructors really do care about each and individual student. And so instead of just like quitting, like, you know, because I got rejected, look at other things, I said, no, like, this is what I want. So I went ahead and researched, and I found out about the enlisted nuclear power propulsion program. So I showed up to the recruiter and I said, I want to be a nuclear operator. And he kind of like looked at me and was like, I rarely have people just walk up and ask for that, but okay. So I took the first test, and I actually failed it for nuke, at least, or to be a nuclear operator. So I went ahead and retook it, and that second time I did much better, but I still didn't qualify for to even be in the nuclear enlistment program. So I went ahead and took a third test, which was just engineering, and I think I passed it by 1 point. So I was able to go through and enlist as a nuclear operator, and then I went to boot camp. And as soon as I graduated from boot camp, I applied again to the Naval Academy. And unfortunately, again, I got rejected. And I thought, oh man, like, you know, my I started to waver a little bit, but I thought, no, 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 like this is what I want to do. So then throughout nuclear power school and the prototype training, which is where you're actually operating reactors, I did very well. And a lot of that's just because it was my passion. So I could sit there and study for 10 hours a day, or like, however long I needed to learn the information, not just to pass the test, but because I genuinely wanted to know this information. So like rather than you have kids who were way more academically inclined than me, who would put in the minimum to pass the test, because the grades don't really matter that much there, or at least everyone thought, until they found out that for officer programs they actually do look at that. So then at the end of my training, the engineers at the end were like, hey, you're like pretty good at this. Have you ever thought about an officer program? And I said I did, but they rejected me twice, and they said this time's going to be different. So I applied again the third time, and I eventually got picked up. And so I've of course came here to the Naval Academy. I chose nuclear engineering as my major, and I eventually will go back to nuclear submarines, which is what I was when I was enlisted, because I absolutely love the community. And I think that time that I got rejected was so important to my development, because I don't think I would have been ready for the Naval Academy just right out of school. So that extra time has built me a formidable amount of knowledge that I can kind of really keep up pace with some of these really smart kids who got out of high school. Of course, I was nowhere near a top student in high school. I was actually slightly lower than average. I graduated 52 out of a class of 90. So unfortunately, I did not perform the best there. But that didn't deter me, and I was very tenacious. I didn't want to give up on my dream. Even though I failed a couple of times, I was like, no, this is absolutely where I see myself. So, and then fortunately, it's worked out so far for me.
Right. Well, I'm glad you made it here against all the odds. And it seems like you're really passionate about it too. I have so many questions, but we'll get to that in a minute. We're gonna hand it over to Arielle really quickly for her to introduce herself. Arielle, do you want me to share your slide from my screen, or do you want to share your slide?
No, if you don't mind sharing the slide.
Just one moment. Sorry about that. Okay. There we go.
Thank you all for having me here today. It was such a pleasure to be invited and to share the stage with Will, who's already had such a wonderful start to his nuclear engineering career. My name is Dr. Arielle Miller. I have been a nuclear engineer for the last 20 years. I also, like Will, was a Navy nuke. So I went to nuclear power school, nuclear prototype. So I started my journey in 1999 when I graduated high school and went to Northwestern University on a Naval Reserve Officer Training Corps scholarship, which is an alternative pathway to get commissioned to the United States Naval Academy. And there are various universities that have either their own what are called ROTC units, or share an ROTC unit with a local university. And I majored in physics because I always loved physics. I thought it was really cool. And at the time, I really thought I'd go into NASA and go to space. Toward the end of my time at Northwestern, it was time to pick a direction to go in my naval career, where I was going to be commissioned in what area at the time. So this is now 2002, 2003. Women were not yet authorized to serve on submarines. They are now. So submarines are now open to women in both the enlisted and officer ranks. But at the time, nuclear was only available to me on surface ships. So if any of you have seen um, Top Gun, especially at the beginning when the planes are launching off of the aircraft carrier that they're launching off of is powered by a nuclear reactor. So I got my interview over at the Washington Naval Yard, and was invited to be a Navy nuclear officer. So I first had to get onto a conventional surface ship and get my conventional surface qualifications. And then I went to nuclear power school down in Charleston, South Carolina, and then prototypes. A prototype is where you learn how to operate the reactor. You learn how to qualify as an operator to actually get to operate a controlled prototype reactor. And then I went to serve on the USS Enterprise, which has since been decommissioned, but was the first Navy nuclear aircraft carrier. And that's pictured down here in the lower right-hand corner. And I got to go on deployment. So I got to do a Western Pacific deployment, which is very rare for a carrier that is stationed on the East Coast. They typically do deployments into Europe. So I got to see a whole bunch of South Asia, and it was really amazing. And then I left the Navy in 2008. I still really love nuclear. I really loved operating. I really loved when I was there learning about the nuclear reactor. I was really good at it. And I wanted to keep going down that road. So I went to work for General Electric, specifically General Electric Hitachi. And I got to work on their advanced reactors. So this was the first time that I learned about different types of reactors. There was more than just the type that the Navy had. So this is where I learned about different types of light water reactors. And then more advanced reactors like the one pictured in the lower left-hand corner there, which is a mock-up of a liquid sodium reactor that is designed to use the used fuel from our current reactors to power it. And I thought, well, that's really cool, because I'm very interested in climate change and interested in the environment and interested in sustainability. And so I really liked how those things dovetailed together. During that time period, after I had gotten out of the Navy, I wanted to continue my career in nuclear. So I went and got a master's degree in nuclear engineering from North Carolina State University while I was working. And that's when I learned how much more there was to nuclear engineering than even what they taught you in power school, which was a lot. Excuse me. And during that time period, I also learned about the professional engineers exam, which is a state issued license. Well, the exam allows you to get a state issued license, which is a very important part of an engineer's career, especially if you want to branch out and be an entrepreneur in engineering and have your own engineering firm. You will need to have your professional engineering license. So I took the exam for that and got my engineering license, and then went on to Arriva, which is a French-owned company. So I've been taking French since I was 12 years old, and I thought this was a really awesome opportunity to take the French that I had been learning and studying, the nuclear, and explore even more parts of the nuclear industry. So here I got to learn about uranium enrichment. And so in those pictures, the middle one towards the upper right-hand corner, or my right-hand corner, those are centrifuges. So inside there are uranium hexafluoride, and we use those centrifuges to enrich uranium so that it can be utilized in reactors for electrical power. And just above that picture is a picture of what the facility would have looked like. We were going to build it in Idaho, but the industry at the time took a turn, and it was no longer financially feasible for us to build it. So I had to find somewhere else to go in Ariva. And I thought, well, this was the front end of the fuel cycle, uranium enrichment. So I thought, well, I'll go to the back end of the fuel cycle. So that's the used fuel. So once you take the fuel out of a reactor, it's still really hot. It's still generating heat, and to some degree, still having fissions that are happening. So you need to store it somewhere until it reaches background levels of radiation. So Ariva designs the storage, or one type of storage facility for these nuclear reactors and their spent nuclear fuel. So that's a picture of what those facilities look like. And we were trying to design, in my group, new products to help make inspections of these things go better, to design better products, to design storage that could be longer or more, you can store more at the same time. So there you see the one where it has like two stacked on top of each other, and then the mock-up of this lift that would lift the cask of spent nuclear fuel into the upper caisson that it would go into. So we were trying to figure out some new designs and be really creative there, which I thought was really cool. Then I had the opportunity to go work in safety oversight for the federal government. So there I was working for a small agency called the Defense Nuclear Facility Safety Board, which oversees the Department of Energy's weapons complex. So not everybody knows, but the Department of Energy is actually responsible for maintaining our nuclear weapons stockpile. And we do so at various sites throughout the United States. So it is the job of the Defense Nuclear Facility Safety Board to ensure that the public is protected while we do those things. So I went to work there and ensure that they were operating safely and handling nuclear material in a safe manner. While I was there, I started and completed my doctoral degree, my PhD, at Howard University, a historically Black college and university in the Washington, D.C. area, in mechanical engineering, with a focus on radiation damage of 3D printed materials, because 3D printing is becoming a more important aspect of the nuclear industry as we need more replacement parts and a better and more robust manufacturing process. I then went back to the Navy to work first at the Naval Research Laboratory, also in DC, doing data analysis, and then on to the Office of Naval Research to help the Navy come up with an innovation process so that they could be more innovative in how they brought new technology on board. And during this whole time period, I started my own business, Dr. Arielle Miller Coaching and Consulting, which does education consulting and PhD coaching, as well as some engineering consulting as well. And I started with a friend of mine a scholarship for young Black women just starting out in their academic careers. So this provides a one-time scholarship to two Black women, either cis or trans, in any field that they're interested in going in at any university or two-year college or vocational institution. And we called it the MGAM Scholarship Foundation. And we just celebrated our third year, and the scholarships are up to, I think, $1,500 per person. And it's been a really amazing thing that I've gotten to do and meet some really great, amazing women just starting out on their journey. And that's me. That's my journey.
All right, thank you. You've worked in so many different parts of the nuclear industry. It's very cool. Even down to 3D printing, which is very high tech and current. But okay, so I guess just a quick reminder to the audience If you have questions, you are absolutely welcome to pop them into the Q&A chat there at the bottom. We'll be taking them and asking your questions. I have a few questions to get us started because, I mean, how couldn't I with those stories? But so yeah, let's dig right in. And please do ask any questions you have. Let's see. All right, so just starting off with a softball, like intro question. You guys touched on this a little bit, but what was really the driving factor for you considering nuclear energy? I know, Will, even you started very young, but how did you know you wanted to go into nuclear energy?
So, I can take this one real quick first. I think what got me on the path to a nuclear career field is two important aspects. One is the media that I watched as a kid. I remember watching a documentary on one, submarines, and two, Chernobyl. Now those now a lot of people would see that and be like submarines and Chernobyl, and you mix the both of them, nuclear submarines. Why would that make you want to join the nuclear navy? But it's significantly different than that. I think the idea though is back then the level of proficiency and importance of your job is what kind of gravitated towards or gravitated me towards it, because most of everyone in society wants to feel important, and that's how I felt like I could feel important, was having a job that's very difficult and that nobody else could really do unless if they worked really hard. So for me, that kind of drew me to it, because I thought like, wow, there's a lot of prestige almost to that job. Very, very similar to like a doctor. Not everyone can go out there and just, perform surgery on a patient. I mean, at least I hope they don't try. But um, I think the idea though is, again, because I wanted to be that person that if I didn't show up to work one day, I would be sorely missed, or I would be needed. I couldn't just, not show up, or some other person could just easily fill my spot. There's so much training required, and again, that goes back to the documentary. Now I know that reactors have gone very far in a short amount of time, and the advancements on them are just absolutely bewildering. But it still though is a job that requires your attention and requires a lot of knowledge, and I really like that it requires you to continue proficiency, and it's something that kind of forces you to be on your toes and not something that you can take lightly. I mean, nobody scoffs at the person who's a nuclear engineer. If all the kids are saying, oh, my dad's this, my dad's that, nuclear engineering is definitely not one that a lot of the other kids are going to make fun of you for your dad being.
That's true. That's true. I know for my job, it does give me a sense of purpose working in nuclear energy, so I can relate. I mean, the nuclear industry is built on just excellence, so I understand that too. Mm-hmm. Arielle, what about you? What drew you to nuclear energy? Oh, you're on mute.
What drew me initially was I saw a lot of career opportunities. So when I was trying to pick which what we call warfare designation I would go into around the time we were preparing for commissioning, and that last year or so, for the longest time I wanted to be a pilot. I thought it was really cool. I thought it would be a really interesting way to get into NASA and pilot a shuttle potentially. But as I started to kind of approach that final decision my senior year, I started to think about like, okay, well, all the different, wickets I would have to hit. And if I didn't get them, right, then, okay, well, then what would I be left with? And would I be okay with what I was left with? And I didn't like the idea of coming out of the Navy potentially with the skill set of just flying, and potentially just flying, commercial airlines or FedEx planes. That didn't really seem like the career path I wanted to go down. So nuclear, having the strong STEM nexus to it. At the time, I didn't know if I wanted to do nuclear, for the rest of my life or not, but I knew that it had a strong enough backbone to it that it could transfer. It could transfer to, if I wanted to go back to grad school, it could transfer to another area of STEM. And that was what made me choose it. It gave me the greatest opportunity for career flexibility in my future. And I already really liked math. And like I said, I was already a physics major. I already really enjoyed it. It wasn't until I left the Navy or was in the process of leaving the Navy and, interviewing for different jobs and, decided to, take the one at GE, see what that was about. At least it would be kind of a soft landing in that first like transitional job coming out of the military. That I had the opportunity to learn that there was so much more to nuclear than just what it is in the Navy. It's so much more than that. And that was what really interested me. What really kind of like, got me to say, okay, this is something that I want to do and I want to kind of commit to it as a career, was the idea that we were designing advanced reactors and we were trying to do something to actually, that there was a connection to help the environment, and that if we did this right, this could be really meaningful to the population. And that was really what got me, was the profoundness of the technology and where it could, go.
Yeah, I know the advanced reactor space in particular is very interesting, especially in the context of climate change. So that must have been exciting. But okay, well, you actually said something that ties in really well to one of the questions that we've gotten from the audience. You had mentioned that you thought that there were a lot of job opportunities. You could go a lot of places with nuclear engineering. And that was actually not the experience of this person. He was discouraged by his teachers. It was viewed as a niche or stagnant field. So how would you convince young people today? What would you tell them about what nuclear could be for them?
So I understand why, especially at that time period in the 1990s, coming off of, Chernobyl and 3 Mile Island and Shurham, there was absolutely a downturn in the industry. And so at the time, like prior to that, all of the jobs in nuclear were primarily around just the commercial nuclear reactors, the light water reactors that they were building or trying to build within the United States. So when that dried up, I could understand why that would be considered not a viable career path. But when I say that there's so many opportunities, I don't just mean that, well, right now we're looking at advanced reactors and microreactors and space reactors and, various types of fuel and closing the fuel cycle and, all different types of things, right? So within that nuclear industry, there's all different types of things that are going on, but they're still like at maybe like what we would call a technology readiness level, like 4, maybe 5, on a scale of like 9. But when you take nuclear engineering, the first thing that you realize is nuclear engineering takes and borrows from all the different engineering disciplines and science disciplines in order to make it nuclear engineering. So you have physics and you have nuclear physics. So you need to understand how the atoms work together. You have chemical engineering as well as chemistry. So that uranium enrichment plant, that's all chemical engineering. The only thing that makes it, special nuclear is the fact that we throw uranium in there instead of something that isn't radioactive. You have mechanical engineering. So, one of the things I say about nuclear reactors is it's just a hot rock that makes steam. It's just a really fancy boiler. So there's other ways that you can make electricity. So there are, there's thermodynamics, there's fluid dynamics. There's probabilistic risk assessment, so you can get more into the statistics of it. There's simulation, so there's transport theory. So there you're looking at simulations that determine and anticipate what your reactor will look like and what or what your system will look like. Well, guess where else they use Monte Carlo? They use Monte Carlo at within the finance sector to determine stocks and bonds. So there are so many different areas that, depending on where you want to go or what you might want to do, that if you kind of come out of nuclear engineering and you're like, it's not really my jam, or I don't want to do light water reactors. There's so many other things that you can do. And that's not even including, you could go on to get your law degree and do intellectual property law. You can become a science writer. There's so many other things that you can do. And this really, because it has all of these disciplines within it, really helps to make you a well-rounded engineer.
I love that. That's so well said. I work in policy too, and that's not super technical, but there's a lot of things you can do that you learn along the way. So,
absolutely.
Will, do you have anything to add?
No, I think Arielle said it quite well. The only other thing I could see is just like medicine, like nuclear medicine is starting to become huge now. I mean, if you think about it, there's like a lot of different paths. You have medicine, you have like the maintenance of the U.S. stockpile, because that's super important because we want to minimize waste. And then you also have, of course, nuclear propulsion and power plants, because if you think about it, how many cargo ships now are out in the ocean pumping diesel into the air? Now you have these massive ships, and nuclear propulsion, then you're really starting to look at something that could really reduce one of the largest polluting sources. So I think that nuclear energy just needs to be a little bit more understood in today's society. And then, so of course, it's a perfect time to really start to get into the nuclear career field, because I feel like as long as people are educated on it, then the whole like job opportunities will just bloom.
So we would kind of touch on this a little bit too. Like there's a lot of skills you accumulate throughout your career. You learn in the nuclear industry. What would you say have been the most important? What have you carried with you that got you to where you are, and you could use elsewhere, I guess? And we can start with Will.
Okay. So one of the most important skills I think I learned is attention to detail. Just how important to make sure to double check things, to make sure that when you make calculations, those calculations are without error. And because it's not something that you can just throw and easily get done in Excel in a couple minutes. It's something that you have to be a lot more cognizant about performing any action involved, in your job. So that's one thing that I think is attention to detail. And then the second thing for that would be a huge work ethic. One thing that nuclear power school taught me was how to study information very efficiently in the shortest amount of time possible, because, you had a test each week. And, as somebody who wanted to perform really well, that was quite challenging. So it really taught you, how to be efficient with reading, how to be efficient with math and calculations, how to do that in as few steps as possible. So that way, you can get more accurate results very quickly, because a lot of times, you don't have time to sit there and, go through this whole, the whole 9 yards of, derivating this equation, when it's like you could have just done that if you would have known this law or that law, and you could have avoided a lot of that. So I think that that's one of the things, or those are two things that I think that, most impacted me that I learned so far in my nuclear career field.
There's more to come, right?
Of course.
It does sound like the nuclear power school was a big point of growth and a lot of skills learned. So it's like a good opportunity.
Absolutely.
Arielle, do you have skills that you want to highlight, I guess, in your career? Oh, you're on mute.
Sorry. So yes, operations. So being in the Navy, both in the conventional warship that I was on, and then, excuse me, on the nuclear powered ship, it was understanding how a power plant operates, and how a nuclear power plant operates. So all the books in the world can only get you so far. Being out on the plant floor, on the shop floor, in the field, watching the gauges turn, having to actually operate this large system and understand how all these systems work together, which just gave me such an appreciation for and took me so far as whether I'm doing safety oversight or design work, et cetera, I'm always taking it from the standpoint of the operator's perspective and how this will operate, and understanding that what's written and what actually gets executed sometimes doesn't completely match.
Yeah, adjusting on the fly and that, maintaining that excellence that we talked about is a tough one. Okay, so we have a question from Amarillo College, who's ANS student section. What was the most difficult aspect, whether it was a course or like just an obstacle generally, for getting into the nuclear field for you? We'll start with Arielle since you're off mute.
So for me, the most difficult thing was transitioning from nuclear training to nuclear academics. So in Power School and Prototype, what they're doing is they're training you. So you are, yes, you're learning theory, but you're learning just enough theory to some degree in order for you to be able to operate and for you to be able to think and understand how the reactor works. But you're not breaking down problems by first principles. You're not doing derivatives and integrals. You're getting very simplified equations in a lot of instances because they need to be simplified in order for you to be able to utilize them effectively in a training scenario. So these are very carefully crafted and designed curricula in order to train you to operate. Now, shifting to going to graduate school and now taking nuclear engineering courses in an academic setting. And now I'm get the definition of a word like the word buckling, but actually mathematically understand what that means. And having been out of, at that point, life for 5 years, I was a bit rusty on my calculus. I was a bit rusty on stuff. And so it was a bit intimidating that first semester, but it was this big eye opener that was, wow, there's so much more here than just what they gave us at Power School. And, but everything's intimidating when you've seen it for the first time. So the more you do it, the better you get at it, or at the very least, the less scary it looks.
Will, do you have things to add?
Yes, I would say for me, it's definitely the rejection letters. Nobody likes being rejected, and so it's hard to keep motivation rather than just drop and give up when you get that letter. And I've gotten plenty of those. That sinking feeling that you're waiting every day for this email from the school, and you open it up and it says, we regret to inform you, and you're like, and the way that I got around that is when I was doing my interview each time, because each application process we have to interview with the commanding officer of whatever, military base we're at. And I was doing mine with him, and I said, "Sir, you're going to see my application pass across your desk every year until either I hit the age limit of applying for the Naval Academy or something is very wrong." So that was kind of the hardest thing, is just trying to keep that, like that motivation, and just, using my dedication to the nuclear career field to keep trying. And even if I wouldn't have got to the Naval Academy, I still would have, very much enjoyed being in the enlisted nuclear Navy. But I didn't know that for sure that I wanted to go, to the Naval Academy. And a lot of it's just because, there's so many graduates from the Naval Academy that go straight into the nuclear engineering field and doing the type of engineering that I wanted to do, because I wanted to be a little bit more, because I was a nuclear machinist mate, basically meant that I operated equipment. I wanted to be a little bit more on like the managing side, to where I kind of did it all, like, because I loved everything about it. I love the chemistry part of it. I love the the actually turning valve stuff, but I also like the control panel part, and calculating rod positioning. So I just saw, that I just wanted to do everything. So that's why one of the reasons I was drawn to the or the officer portion in general. And of course, just keeping that in mind, keeping what do I really, really want, and how can I keep working towards that. So even though I got rejected and stuff like that, I thought, hey, there's still another year. I'm not going to give up.
I'm just generally very impressed by the amount of passion that you have both brought to this. Let's see. We have, I guess I'll tie together a couple quick questions here, because we've gotten it from two folks. Would you say that the U.S. has adequate educational opportunities for kids looking to go to the nuclear industry, or maybe who haven't even considered it? And are there any missing elements, I guess, that we should add to it, especially if they don't want to go specifically to nuclear power plants, but maybe they want to do isotope production, or go into medical fields or other things?
So I'll start that one off. I think that for isotope production in general, that is more of a chemical engineering thing, because you're not just, so uranium enrichment is one type of isotope production. So what I learned when I left the Navy, and even when I honestly left GE and started venturing out into the what is called the front end and then the back end of the fuel cycle, basically that prior to the fuel getting delivered to the reactors and then put into the reactor, and then everything after it comes out of the reactor. So basically everything outside of actually operating is the front end and the back end of the fuel cycle. And I learned is that because when I was reading the person's question, is like, it seems like the education system, at least in the universities, are very focused around reactor operation. And that is true. That's a true observation. And what I learned was so much of it is really not nuclear specific. It's like nuclear adjacent is what I talk about. Like it's heavily chemical engineering, whether you're enriching, it's a lot of chemical engineering. There may be a lot of mechanical engineering in there. But it's not that much nuclear, because you're not, all you have to do when it's outside of the reactor is just keep it in a stable state so that it doesn't go critical. So that's kind of the level of nuclear. And so that's really called criticality safety. So I know that the University of Nevada, Las Vegas focuses on criticality safety, and that, you know, the industry as a whole, and I sit on the division for nuclear criticality safety. They have been working with various universities to build up that program, to build up that particular subset of folks that understand that and are trained in that, because that really spans a lot of the other stuff that goes into nuclear, whether it's like the medical community, or like I said, isotope production, and you're talking about uranium, it's criticality safety. If you're talking about just in general isotope production, then you're really talking about nuclear physics or atomic physics, a bit of chemistry or chemical engineering. So, you know, I know that this is kind of around like the nuclear engineering, you know, courses and discipline, but you can still get into that industry without a nuclear engineering degree, and or, you know, nuclear adjacent stuff without the nuclear engineering degree. It can be physics, it can be chemistry. There's whole fields within chemistry on the chemistry of uranium, or the chemistry of plutonium, or the chemistry of other transuranics or actinizer, you know, different elements, and how they go into different alloys and phases and all this other stuff. So there's all of these different areas. But when you're talking about nuclear engineering as an area of study, it does focus on how you maintain a critical safe reactor and everything that goes into that, and everything, and how the physics of fission work. So, for example, it's not really going to go into other types of ionizing radiation, with maybe the exception of gammas, right? It's not going to go into protons. It's not going to go into heavy ions. That's going to be more in your nuclear physics area. So it really kind of depends on what area you want to focus
on. Okay, thank you. So we're technically over time, but Will, if you have something to add, you can keep it really quick.
Yeah, sure, absolutely. I'll just add a couple of tidbits real quick. One thing that I really like what Arielle said was that you don't need a nuclear engineering degree to work in the nuclear field, especially like, you know, at the Naval Academy. That's my best example, like, you know, because that's currently, like, you know, what I see each year is that, you know, usually there's anywhere from 15 to 20 students who graduate with nuclear engineering, but then there's 150-ish people who go to jobs with nuclear reactors, so whether that be submarines or aircraft carriers. And then the second part of that, I actually really like that question, because where do I think that like the education system basically kind of like fails high schoolers in decision making for jobs, especially in something like nuclear, is there's so many jobs out there. How are high schoolers supposed to figure out what they want to do? They're kind of figured out, so they're kind of forced to choose their degree first. But how do they know what degree they need if they don't know what job they want to do? So I think that the important thing to kind of like help fix that is just, you know, certain things like a lot of the textbooks we use is a little bit outdated when they talk about nuclear engineering. And I don't think that, you know, people are exposed to what kind of jobs, and this is like goes beyond just nuclear, to any kind of jobs. You know, there's like there's so many different things that you could work in for nuclear, and a lot of people aren't ever taught that or even know that. I mean, there's plenty of adults who don't. So I think that that's one thing that's kind of something that I hope to see more in the future, is almost like, you know, like like high schools involve more something like a job fair, to where people come in and get a talk about, you know, different opportunities for them in the future, so that way they can choose what job they want first, and then they can ask themselves, okay, what requirements do I need to make to get this job? Because then they have like kind of like a goal to where, okay, I need to get this, and that done to be able to get the job I want, rather than, you know, go to college, do a major, I don't really like this major, and then kind of switch, and then, you know, kind of jump around job for job. Or when they graduate from college, they're like, I don't know what job I want to do. And I think that that's one thing that we could definitely improve on in the future and going forward.
I like that. And just increasing the support system for that decision making, and not having a counselor or your mentors, I guess, like respond like yours did, I guess. Like, you want to be a nuclear engineer? You want to go work on a nuclear submarine? So anyway, well, thank you everyone for joining us. This has been a really wonderful discussion. Thank you for all the questions. And thank you to our panelists, Arielle and Will. We really appreciate you being here. Let's see, and you keep an eye out for the recording of the session that should be coming out later today. And that's all we have, folks. All right, have a good afternoon.
Thank you.
Thank you.